This is one of my favorite little demonstrations to do for this class. We want to talk about triangles versus, say, a square or a rectangle. And we talk about how triangles are rigid and stable. And so what do we mean by that? Well, we mean that if you have a triangle, and this one is made just out of popsicle sticks, if you have a triangle and you push on a side, which in this case I'm also pushing on the vertex, it doesn't deform. I would have to push hard enough to either break the way that the sticks are connected or break the sticks themselves in order to deform it. And on a square or something like that, a rectangle or a square, all I have to do is push and it deforms. It collapses. And it's that easy. I can push on a vertex and it deforms. I can push on a side. Let's say I hold it here and I can push on a side and it deforms. So squares and rectangles, they're not stable, they're not rigid the way that they're constructed. And so usually when I show people this, they say, well, you've done something different to the way that the triangle is constructed. Like the square has pivots on the corners. That's why it can deform. Well, sure, I have pivots on the corners so that I can show it to you and then, have the gadget left over to and not broken to show you or show other classes in the future. But let's look at the triangle. I can take it apart and you can see that there are pivots on the corners, on the vertices. And yet, when I put it back together again and I push on it, it's rigid and stable. And so usually then the next question that people ask is, when I look at buildings, most buildings, their walls are made out of squares or rectangles. Why don't they fall down? And the reason is that if you look at the way walls are built, if you ever look at new construction on a wall or a home, you'll see that they'll often have a cross brace, some sort of excuse me, some sort of stick or board that's put across, and it'll form a triangle. And once that board is attached, then it forms this triangle, excuse me, and it's attached to the square like this, and suddenly the square is stable. And that's because a triangle was introduced. And the only time that the square with the triangle becomes unstable is if we lose that connection, and then the square can deform. Fun stuff. Always fun to just take my little triangle here and make it all wobbly. And then put it back together like that, and suddenly I have stability.